Okay, let's start with this. We have quadratic inequations. What makes it an equation an inequation?
Because it's not equal to.
Makes sense. No equal signs are involved. You're only dealing with that, that, and that. Okay, that's inequations. So over here, if you were asked to solve x squared plus 3x minus 10 is greater than 0. Like what you normally do, I've already got the solution there. Let's write it the other way. We are first going to treat it as an equation first. That's our foundation. But then we'll disregard it later once we have a visual. Likewise, we use our trinomial. Perry, what goes in front without looking at the TV? Okay. What two numbers multiply to negative 10? And then when you put them together, add, subtract, they come to 3x. We can see there. It's 5 and a negative 2.
How do you know not to do -5 and 2?
Okay, so if it was this way, what question's that? -5 and positive 2 does the negative 10. But if I combine a negative 5x and the outside plus 2x, it's a negative 3x, which we don't want. Okay. That's okay. Okay. And let me just get my notes here. So first of all, once we get to this stage here, we can see that our solutions for our quadratic are going to be what our solutions are.
-5.
Not quite.
5 or -2. So
5
it's negative.
Oh, sorry. So you were right. Sorry. Yeah, thank you. So technically you're right, Hudson. And thanks, guys, for picking that up. Okay, so back to the actual solutions. -5 and 2. Thank you. Thanks for not making me look stupid on YouTube. I had 2 views in the last video.
Who?
Yeah. I wonder who they were.
That was me.
That was you. I think so. Who's the other one? It's good to know I've got.
Do you watch it? It's might have been you.
No, I don't. I don't watch myself. I prefer not to watch myself. I'm getting better at it. At looking at myself.
So,
What?
there's no need to be ashamed.
Yeah. Not. I think ashamed is a strong word. I guess more self-conscious.
Nah. You're a handsome bloke, so
Oh, thanks,
in
mate.
action.
I'll write that down in my diary. That you said that.
Oh.
Okay. They said I was handsome. On 28th of February, 2025. It'll, every time I feel sad,
Yeah.
it's 10 to February 28th. Okay, all right. So you just punch them in, -5 and x equals 2. Now, in this case here, we're not worried about intersections and stuff. We're just worried about the general shape. We know what type of quadratic is this? Is it a normal or upside down? You know, it's a normal because of the positive x squared. Therefore, it must follow that. That is now gone. Must follow that. Let's just, for the video, make it look clearer. It's messy. But we haven't actually solved the question. Okay. We want to solve when the graph is greater than 0. But when we solve something, we're looking for x values. Remember, when you solve something, you're looking for x all the time. Solve x, solve x, solve x. Here, we're looking for these x values that are greater than 0. But we've done an equal sign. The only reason why we did an equal sign is so that we could make sure we draw the graph correctly. If I'm positive, I'm going to use the blue pen for this graph here. Where do I trace on this graph that is positive, that is blue?
The
top
two
half
lines above the X.
Okay, so the top half gets covered. Next question, am I going to include the horizontal or not, where it cuts through?
No.
Why does Gabe say no? Does anyone want to?
Right.
Amy, the whole thing equals 0. Okay, we want to leave these open because we're actually not interested in that. We are interested in greater than 0, so we don't touch it. So that's positive. If the question was asking for negative, you may want to put that in red. Negative, bad, corrections, all that sort of stuff. Okay. But you don't get marks for coloring graphs in. Okay, this is not primary school. You get marks for explaining this in mathematics. So if I want to find out when this graph is blue, how do I write that with maths? Any ideas? Remember, we are after x values. Who wants to have a go?
It's greater than
X is greater than
the -5.
Okay, not quite.
0.
We need not quite. We remember we're talking about there's two things happening. There's horizontal that we're looking for. I got that wrong. Okay. There's vertical and then there's horizontal. The answer is what horizontal numbers answer your vertical numbers. Okay, what is the x values that determine the y values?
Is it not -5 and 2?
It is, but how do you write that?
Yeah, when x is greater than -5.
No,
X is greater than 2.
x is greater than 2.
And x is smaller than -5.
Excellent.
Oh, because it's going down.
Okay.
No.
Okay.
Okay.
Okay. Okay. I'm going to put this up here. I'm only interested in blue. But think about, yes, blue is y, but we're interested in the x values. At this stage in the graph, x is greater than 2. Let's have a go at this side. I'm going to cut it like this. I'm only interested in blue. We already know that blue is up. But the x values that are involved with this being up are all the numbers that are less than -5. Okay. And then because they're broken up,
It swings.
Yeah, it swings through, and then that half swings
Yeah.
through is negative.
Yeah, that's right. So if we have a little roller coaster happening, okay, Disneyland is going down. It's still positive, 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 but the x values
Okay.
are -5.
Yeah.
If we go here, it slowly goes down in the valley and then up again, has a breath of fresh air. At this point in time, we're now positive again, but the x values are more than 2.
Yeah.
Okay, this is can be really confusing. If you feel confused, that's normal. Okay. We need to unite our blue. How do we unite things? How do we marry things in methods? Union. Okay.
I can do that, but I'm going to put the right inequation like I do the other way.
It takes okay. It takes practice.
Yeah.
It takes practice.
What's the upside down union again?
That's an intersection.
Yeah.
Okay. One more example, then we're done. You'll get these notes.
I can focus.
I wish I could just be.
Find the points. Last one for today. Very common question. Very common question that's assessed. Okay? Read between the lines. Okay. Find the points of intersection of the parabola y equals x squared minus 3x plus 2 and the straight line y equals x plus 3. So we are dealing, just to lead us up, we've got a parabola. And it says a straight line. When we place them on a graph, they're going to do this somehow, like that. Okay. Somehow. We'll get to the graph later. You can answer questions without drawing the graph. When you hear the word intersection, what does that start kicking into place? What words? Intersection. I've got intersections here. I've got 2 intersections. What is the word, the most logical word?
Solution.
Solution. Yes. Let's go further. Let's go further.
Experiment.
No. That's okay. Okay. So it starts with E. The word intersection is related to the word equal. Who was going to say that? Was someone going to say that? You're going to say it. Have faith in yourself. Rita. Have faith in yourself. Amy. You guys, you got to back yourself.
Now check. Yeah.
Oh, shh. Back yourself. Out to Zane.
Yeah, I was just reading something.
Was reading his palm.
Yes.
What's his future? What is Jesse's future for the next week?
He's going to come across great fortune.
Make the NBA.
Amrita, you may. Okay. Black intersections here represents when they're equal. So naturally, we want to find out that is also gone.
A good day of the month.
Yeah.
If I've got our two graphs, we're interested when they hit. When they hit are solutions, as Hudson said. When they hit, they're intersections. But mathematically, when they hit is when they are equal. Graph 1 is equal to graph 2. And that's going to help us to find out intersections.
Good.
What are we going to do now?
Take away the 2.
Algebra.
Take away the 2 on the other side.
Find x.
Okay, so 3 is there. Take away the 2.
So it's x plus 1 on the other side.
X, yep, it will be plus 1 on the other side. What else should I shift over?
Negative 3.
And the 3, yeah, the negative 3x. So you
Okay,
add
the
3x
negative 3.
onto both sides.
Okay. I'll just see where you go with this. Okay.
You should just divide it.
Okay. Are you okay with that now?
Yes.
Okay, I'm not.
No. No, I'm not either.
I'm not. Thank you, Jesse.
That's why we should have divided. Nice.
We want the x's on one side.
Right formula.
You can use quadratic formula. Correct him.
No. Too long.
I don't know.
Now, is there a way to do this without the too long quadratic formula? Can you break what's something times something is a -1 that equals -4? Good. It's a very good question.
It's impossible.
It's
Negative. Yeah.
you do it in your head, Tim. That's impressive. Okay.
Is it? Wait. Is it add,
Yeah,
to,
it's
add to give -4?
Add to give.
Is it add to give -4?
Yeah.
Yeah, it's the other way around.
Yeah.
Oh, so 1, 1.
Okay. You can't. I'm saying you can't break it up. We're going to go with Tim.
You can't.
Quadratic formula.
You can't. Yeah, it's very nice. Quadratic formula.
It is. That's your backup all the time. But if there's a quicker way, you take it. If you can't take it, you got to go the long way. Just like in hiking, you know, if there are no shortcuts, you got to take the long way that they gave you. Okay, B. -4. Okay, just punch them all in. Like so. And from here, you should be able to get it. +4. 16 plus 4. Let me know if I've made a mistake. 4 plus minus √20 over -2. How do I make this more simple?
Multiply each side by -2.
Not quite.
Okay.
You could if there was a 2 in here. Okay. How do we reduce our square roots? What is the thing?
4. We'll make it 2 √5.
Thank you, Tim.
Excuse me.
We're gonna explain what Tim just said in his mind.
4 times 5.
Yep. You must.
And that becomes 2 √5. One
Yeah.
week.
The key to surds or square roots is to find the square factor. That 4 is really important. Lastly, we just keep going. We break it up. Our √4 changes into a 2 and a -2. We apply the -2 to each. What does this mean? For our x,
you get rid of the 2 in front of the square root? Multiply. That would be different.
Yeah, so 2 and 2 is a 1.
Yeah.
It's a 1 in there. Okay. So we have a -2 plus root 5 in here, and a -2 minus root 5 in here, which is our intersections. How do we find our y's? We substitute. Where?
The x.
Which one?
It's the one and one right.
The one on the right. So Tim is saying you will get.
We whack it back in the x squared minus the
You
x.
do, but you've got a choice now. Why is Tim saying to put it into this one? Why not that one?
Because it's shorter.
It's shorter.
easier.
You'll get the same answer.
So why did we pick the one on the right?
Because it's an easier
No,
equation.
sorry.
The factor.
They're both. These are coordinates now.
Yeah.
Which one do you
Yeah. So why did we pick the
They're
one
both.
on the right?
They're both.
Oh, so you can chuck either of them in.
You need to chuck both of them in.
Okay.
I'll put.
parabolas like two.
Well, in this case, intersections with the
Gotcha.
graph. Okay.
So how do we put?
So here,
We're gonna do this twice now.
yeah, but it's really easy. Well, like that. That's it. Well, let's clean it up. 3 take away 2. 1 plus root 5. That's 1. So down here, this is now 1 plus root 5. We do another one. This will make sense in a second.
1 minus root 5.
Minus root 5. Let's take the shorter way, x plus 3. It would still work with the other one. What are we left with?
1 minus 5.
1 minus root 5. Okay. So we have over here 1 minus root 5.
Those are intersectional minus.
Yes. Yeah, we're just finishing soon. Yeah. Yep. Lastly,